Hello. If you recall in our last video lesson, we went over how to model real-world scenarios using linear functions, answer word problems related to them, and graph them. So we went over kind of the general basics of how I like to go about solving those problems, and then we did an example based on someone earning money over a summer job. So today we're going to do just another example of a different type of problem you might see, but we can model it using the same kind of tactics. So let's start out by writing down our problem. So Bill starts in Mount Pleasant. He runs at a constant pace, covering 18 miles in 3 hours. Assuming he continues this pace, how long will it take him to run from Mount Pleasant to Provo, which is about 60 miles? And how far will he have run after 5 hours? Okay, so in this question we have a lot of information there, a lot of words, and we want to try to put it into a mathematical form that we can model it with. So, just like the last one, I'm going to try to put it into the form y is equal to mx plus b. So, if we want to identify our dependent variable, we want to think about what we're modeling that depends upon something else. So what I'm seeing is that we have time as one of our variables. How long will it take him? And if we recall, time is almost always our independent variable. And in this case, it's going to be his distance that depends upon how long, how much time he runs for. So I'm going to model the y is going to be our distance, our dependent variable, and h is going to be how many hours he runs. So we have 2 slots to fill. We have the slope and our initial value. So to find the slope, we're actually going to need to do some work here. So recall that our slope is equal to our change in y over our change in x. And we're not just flat out given our slope like we were in the last problem. However, we are given this information that he starts in Mount Pleasant, he runs at a constant pace covering 18 miles in 3 hours. So 18 miles, that's our distance. So our change in y is going to be 18 miles, and our change in x is going to be 3 hours. So if we do this division, we find out that his pace is 6 miles per hour. And that speed is going to be our rate. Our initial value, this is a little bit of a trick question. if he's starting in Mount Pleasant, we can define Mount Pleasant as being at a distance of 0. So in that case, we won't have an initial value, so it'll be equal to 0, and we'll just have d, which would be our distance in miles, is equal to 6 times the number of hours, and then our initial value is equal to 0. So let's graph this. Like our last scenario, we're only really interested in positive miles and positive time. So we'll have h, which is our hours, on this axis, and we'll have d, which is our distance, on this axis. So we're going to have to make a scale. If he's going at 6, 12, 18, 24, and we'd have 30, 36, 42, 48, 52, or 54, 60. We could have our hours, we could just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So our initial value, which is the same as our y-intercept, is just going to be 0. So we have a point over there. And our slope is 6. So for each 1 hour, he'll go 6 miles. So we can just plot each of these points. And that is an appropriate model for Bill's distance from Mount Pleasant. So if we want, now we want to look at our questions. We have, how long will it take him to run from Mount Pleasant to Provo, which is 60 miles? So to answer this, we want to plug in 60 as our distance and see how many hours that will take. So once we plug in 60 for our distance, we have a single variable equation. So if we divide each side by 6, we'll see that it will take him 10 hours. So we can answer that it will take him 10 hours to run all the way to Provo. That's a pretty long distance. And then if we look at our graph, which is probably not perfect, we'll see that if he runs 60 miles, our graph isn't perfect. You see, it's giving us that he'll run that far in 12 hours. But that's just because I didn't graph the line perfectly and our lines aren't perfectly delineated out like that. So if I used a ruler and plotted this on graph paper, I would have gotten that it would take him 10 hours to run to Provo. Then we're asked how far will he have run after 5 hours. For that one, we're going to plug in 5 for h. So we'll get d is equal to 6 times 5, which is equal to 30 miles. So after 5 hours, you see, this one worked out a little bit better. It'll be about 30 miles after running for 5 hours. So we'll see a lot of these kinds of word problems where we have distance and time and speeds. And some important things to note are that your speed, so in this case 6 miles per hour, is always going to be our rate. Our distance is always going to be on our y-axis, or our dependent variable. And then h, hours, our time, whether it's in seconds, minutes, hours, days, years, is always going to be on our x-intercept. So again, that's just another example of how we would model a real-world scenario using linear equations. And hopefully it's helpful, and in our next video, we'll go on to this same process, modeling real-world scenarios, but we're going to use linear inequalities. So stay tuned for that.